Hi there, this is going to be a quick review for solving equations from week 3. First, the steps for solving linear equations. We're going to clear any grouping symbols, get the variable terms on one side and the numbers on the other side, combine your like terms, and then the last step will be to multiply or divide to solve. Okay, I'm going to run through a couple examples, one that contains parentheses and all those steps above, and then I'm going to do a couple equations, one for clearing fractions and one for clearing decimals. Then we will move on to absolute value. Okay, here's my equation. The first thing I need to do is multiply through by 5 and then multiply through by my negative to clear my parentheses. Okay, in the second line you see I've cleared my parentheses. Then I combined my like terms to get 4x minus 7. At this point, I need to get rid of the minus 7, so I'm going to add 7 to both sides. My next step is to get the x terms on the same side, so I'm going to subtract 2x from both sides. Then my last step would be to divide both sides by 2, and my answer is x equals 11. Alright, this next problem I want to look at simply because there are fractions. If you have fractions in your equation, what you need to do is to figure out what your LCM is, and that's the least common multiple for your denominators, 3 and 6. The smallest number that they will both go into is 6. What we do then to clear the fractions is we multiply all the way through all terms by the LCM. Alright, then what happens is I can cancel, and over here 6 goes in here once and in here once, and I end up with 2x plus 48 equals just 1. That's a very simple equation to solve. You see that I need to subtract 48 on both sides. That leaves me with 2x equals a negative 47. I'm going to divide both sides by 2. And my final answer is then x equals negative 47 halves. And you can leave it as an improper fraction as long as it's simplified. Alright, if you have an equation that has decimals, you need to figure out which power of 10 you need to multiply in order to clear all the decimals. This has 2 decimal places, this has 1, this has 1. In order to clear all of them, if I just multiplied through by 10, it would move the decimal point over one place, but I need to move it over 2 for this number. So what I'm going to do is I'm going to multiply all the way through both sides by 100. Now what happens when we multiply all the way through by 100 is the decimal point gets moved over 2 places here, 2 places here, and 2 places here. Now, that means I have to put a 0 in here and a 0 in here. Now, as you see, I get an equation that has no decimals in it at all, and I can solve it like I solve any other linear equation. Once the decimals are cleared, we can subtract 475x from both sides, then divide through by 245, and I simplify that fraction to get x equals 6/7. Alright, let's take a quick look at solving linear inequalities. You'll notice the steps are identical. The only thing that's changed is in bold, where it says if you multiply or divide by a negative number, you must reverse the inequality. So let's look at an example. Alright, the first thing we need to do is multiply through by our negative 7 to clear our parentheses. Alright, I've cleared my parentheses and combined my like terms. Now I need to get the numbers on the same side, so I'm going to add 7 to both sides. And that gives me 16 is less than negative 8x. Alright, now my next step is to divide both sides by negative 8, but a little warning bell should go off when you start to do that, because if I divide both sides by a negative 8, I have to flip the inequality. So what I want you to do is just color that really big on top of there. so that you get it flipped right away. Don't forget to do that. Then you end up having negative 2 is greater than x. Now usually when we read inequalities we want the x on the left. So if you're going to write the x on the left, just make sure your inequality continues to point at the same number. In this inequality, it's pointing at my x, so make sure it's still pointing at the x. Okay, we've got x is less than negative 2, and we need to graph that on a number line. So what we do is we take our pencil, and if it's less than negative 2 and there's no equal bar, we're going to put an open circle around negative 2. Alright, and then to finish that off, I need to include all the values to the left of negative 2. So I'm going to color in the arrow as well as all the points to the left of negative 2, and that's the graph of x is less than negative 2. Okay, let's talk about absolute value. The definition of absolute value is the distance that a number is from 0 on the number line. So if I ask you for the absolute value, as symbolized by these vertical bars, the absolute value of 3 is the distance that 3 is from 0 on the number line, which is 3. If I ask you for the absolute value of negative 7, the distance that negative 7 is from 0 on the number line is 7. The absolute value of 0 would be 0. The absolute value of negative 41 would be 41. The absolute value of 8 is 8. So the absolute value is always positive. It's never negative. It could be 0, but it's never negative. Okay, here are 3 equations that have absolute values. In the first one, if I want to know what number of x has an absolute value of 6, the answer is x equals 6 or x equals negative 6. If I say the absolute value of x equals 10, I know that x must be 10 or x must be negative 10. Now over here, when I start drawing clouds, then that means we're starting to talk about quantities. I know that the cloud has got to equal 8, or the cloud has to equal negative 8. Okay, let's look at a problem that has a quantity between the absolute value bars. I want you to think of this as being the cloud. So when I did that before, cloud equals 7 or cloud equals negative 7. So I'm going to write x minus 3 equals 7 or x minus 3 equals negative 7. Now notice I didn't make that minus a plus. Don't touch what's in the cloud. Write it down and say it has to equal 7 or it has to equal negative 7. Now you have 2 equations, solve them. When I work out both equations, I get x equals 10 or x equals negative 4. Those are the numbers that I put in for x that make that a true statement. Just want to make a quick comment about absolute value equations because sometimes they will have something that's outside the absolute value symbols. And now, before you can break this down into 2 separate equations, you have got to isolate the absolute value. That means you've got to get rid of that minus 4 first. Okay, I've added 4 to both sides. Now I have the absolute value of some stuff equals 14. I can write down my 2 equations connected by the word or and finish the problem. So we end up with x equals negative 21 halves or x equals negative 7 halves. So to summarize, when you're solving absolute value equations, isolate the absolute value quantity by adding or subtracting if necessary, and then write 2 equations connected by the word or. Solve each equation, and you're done.